so we're first going to use partial fractions to simplify this rational expression. So we will need to factorize the denominator in order to do so. So we have 2x and x, 4 and 1, plus minus. So this will equal a over 2x minus 1 plus b over x plus 4. Will be a times x plus 4 plus b times 2x minus 1 over 2x minus 1 times x plus 4. That equals 11x plus 17 over 2x minus 1 times x plus 4. We're now going to equate the numerators. So if you look at the coefficients of x, on the left we have 11, on the right we have a plus 2b. So a is 11 minus 2b. The constant 17 equals 4a minus b, so b equals 4a minus 17. So b equals 4 times 11 minus 2b minus 17. B equals 44 minus 8b minus 17. 9b equals 27. B equals 3. And therefore a equals 11 minus 2 times 3. 11 minus 6 is 5. So 11x plus 17 over 2x minus 1 times x plus 4 equals 5 over 2x minus 1 plus 3 over x plus 4. We're not going to leave it there. I'm just going to check the solution. So we'll have 5 times x plus 4 plus 3 times 2x minus 1, and this must equal 11x plus 17. So we have 5x plus 20 plus 6x minus 3. 5x plus 6x is 11x, 20 minus 3 is 17, so this is correct. So we can write this integral as 5 over 2x minus 1 plus 3 over x plus 4 dx. I can split this up into two integrals. So the integral of 5 over 2x minus 1 dx plus the integral of 3 over x plus 4 dx. I'm going to pull out the constant term here. So to take out the 5, we have the integral of 1 over 2x minus 1 dx. Likewise, we take out the 3 with the integral of 1 over x plus 4 dx. The integral of 1 over 2x minus 1 will be ln 2x minus 1. But because we're integrating, we get dividing by the derivative of x. So that's divided by 2 plus 3 times the integral of 1 over x plus 4. It's going to be ln x plus 4, and the derivative of x is 1. And then we add our integration constant. So we'll have 5 over 2 ln 2x minus 1 plus 3 ln x plus 4 plus c. We can leave it like that, or we can try and clean it up a little bit. So we'll have ln 2x minus 1 to the power of 5 over 2 plus ln x plus 4 cubed plus c, and that will be write as a single log ln 2x minus 1 to the 5 over 2 times x plus 4 to the 3 plus c, and that is the final answer. Okay, with this example, your first instinct would probably be to factorize the denominator, okay, which is x minus 2 all squared, and then write down a over x minus 2 plus b over x minus 2 all squared. So on the right we'll have a times x minus 2 plus b, and on the left 3x squared minus 10 over x minus 2 all squared. Now we can't proceed as we normally do by equating the coefficients, because if we start with x squared, we've got an x squared term on the left. We're just looking at the numerators now. There's no x squared term on the right. That's a problem, because we need to decompose this rational expression into partial fractions and somehow get a 3x squared term out of that. Now, you can try this. You're not going to get a 3x squared term out of this, no matter what you do. So we can't approach it this way. We're going to have to approach it another way, and that way is to divide this expression here, the numerator, by the denominator. Okay, well, this example, if the degree of the numerator is greater than or equal to the degree of the expression in the denominator, then we're first going to have to divide the polynomial. So if we call 3x squared minus 10 p of x and x squared minus 4x plus 4 q of x, then we first need to divide p of x by q of x, get a remainder, and then we can use partial fractions. So that's the first thing we're going to do, is we're going to divide these polynomials. Now to do so, we need an x term in here because we have an x term there. So we are going to add, because there's no x, we're going to add that, z plus 0x minus 10, and we're going to divide. And so x squared divides into 3x squared 3 times, and then 3 times x squared is 3x squared, 3 times minus 4x is minus 12x, and 3 times 4 is 12. Then we subtract these expressions. So 3x squared minus 3x squared is 0. 0 minus minus 12 is 0 plus 12x, so it's 12x. And then minus 10 minus plus 12 is minus 10 minus 12 is minus 22. So 3x squared minus 10 over x squared minus 4x plus 4 equals 3, which is the quotient we got here, plus the remainder, so we can call that r of x, 12x minus 22 over q of x, which is x squared minus 4x plus 4. Now we're going to check this first to make sure that we get 3x squared minus 10, otherwise we're going to be wasting our time continuing with the problem. So we're going to get a denominator here, x squared minus 4x plus 4. So at the top we'll have 3 times x squared minus 4x plus 4 plus 12x minus 22. So just multiplying out the numerator, we'll have 3x squared minus 12x plus 12 plus 12x minus 22, and it'll give us 3x squared, that'll cancel, minus 10, which is exactly what we have over there, right? So this expression here is what we're going to use. So we have 3 plus 12x minus 22 over, and we're going to factorize this as x minus 2 all squared. Now we're going to ignore the 3 for now. We'll worry about this once we've written 12x minus 22 over x minus 2 all squared as partial fractions. So 12x minus 22 over x minus 2 all squared will be a over x minus 2 plus b over x minus 2 all squared. Okay, so getting a denominator on the right, lowest common denominator, x minus 2 all squared, At the top we have a times x minus 2 plus b, and that equals 12x minus 22 over x minus 2 squared. Now we're going to compare the coefficients of the numerators. So starting with x, we are going to have 12, coefficient of x. Coefficient of x on the right is only a, right? That's the only expression we're going to get there. So a is 12. The constant is minus 22, and that equals, the constant here will be a times minus 2, so minus 2a and b. So b equals 2a minus 22. A we know is 12, so it's 2 times 12 minus 22. B is 24 minus 22, which is 2. So this will be 12 over x minus 2 plus 2 over x minus 2 all squared. Let's just check that this does give us this expression here. Recall that we had this expression was 3 plus, right? So we're just going to double check that this expression here on the right will give us this expression here. So we have 3 times x minus 2 all squared plus 12x minus 22. That's 3 times x squared minus 4x plus 4 plus 12x minus 22. I'm not going to write the denominator down just for space. So we have 3x squared minus 12x plus 12 plus 12x minus 22. 3x squared minus 10, right? So we're just looking at the numerator now. The right hand side will have x minus 2 all squared. We'll have 12 times x minus 2 plus 2 plus 3 times x minus 2 all squared. So it's going to be 12x minus 24 plus 2 plus 3 times x minus 2 all squared. That's 12x minus 22 plus 3 times x minus 2 all squared. I'm not going to multiply this out again because you can see that this expression here is that expression in the numerator, and we've just multiplied this out here. So everything checks out. So we now have the integral. We can write this expression as the integral of 12 over x minus 2 plus 2 over x minus 2 all squared plus 3, and this entire expression dx. So now we can write this, express this integral as 3 separate integrals. You don't have to. You can integrate as you go along, but it's just sometimes nicer to write it as separate integrals. So 2 over x minus 2 all squared dx plus the integral of 3 dx. Okay, we can pull the constant out. So I'm just going to write this out again in a different form. So 12 times the integral of 1 over x minus 2 dx. We're going to pull the constant 2 out, and we have 1 over x minus 2 all squared, which I'm going to write as x minus 2 to the minus 2 dx. And 3, we're going to pull that constant out. So we just have 1 dx. We don't even need to put the 1 there. So we're going to just put dx. Okay, so that equals 12 times the integral of 1 over x minus 2 dx is going to be ln x minus 2. We also divide by the derivative of x, which is 1. So dividing by 1 doesn't change anything. Then we have plus 2 times, we're integrating x minus 2 to the minus 2, so we're going to add 1, so which means we'll have x minus 2 to the minus 1, and then we divide by this exponent minus 1, so we're just going to put a minus in front of that, plus 3, and the integral of 1 dx will just be x, and then we add the integration constant. Okay, so cleaning that up, we get 12 then x minus 2 minus 2 over x minus 2 plus 3x plus c. That is the final answer. Okay, in this example, the numerator will not factorize, but the denominator will. So we have x squared minus x minus 21 over the first two terms. We're going to take out a common x squared, and we're left with 2x minus 1. And from the last two terms, we're going to take out a common 4, and we're left with 2x minus 1. So that equals x squared minus x minus 21 over 2x minus 1 times x squared plus 4. So as partial fractions, we're going to have a over 2x minus 1 plus bx plus c over x squared plus 4. So we'll have a times x squared plus 4 plus bx plus c times 2x minus 1 over 2x minus 1 times x squared plus 4, and that equals x squared minus x minus 21 over 2x minus 1 times x squared plus 4. Okay, so comparing the coefficients, we'll start with x squared. On the left we have 1. On the right we'll have a plus 2b. So a equals 1 minus 2b. Then we'll do likewise with x. So on the left we've got minus 1. There'll be no a here because there's no x term. We will have minus b plus 2c. So b equals 2c plus 1. And the constant term is minus 21 equals, we'll have 4a. So these two terms here. And minus c. So c equals 4a plus 21. So c equals 4 times 1 minus 2b plus 21. C equals 4 minus 8b plus 21. C equals 25 minus 8b. So b equals 2 times 25 minus 8b plus 1. So we're just subbing here. B equals 50 minus 16b plus 1. 17b equals 51, which means that b equals 3. So a equals 1 minus 2 times 3. 1 minus 6 is minus 5. And then c is 25 minus 8 times 3. 25 minus 24 is 1. So x squared minus x minus 21 over 2x minus 1 times x squared plus 4 is written as minus 5 over 2x minus 1 plus 3x plus 1 over x squared plus 4. We're just going to check that this is in fact correct. Otherwise we'll be wasting our time with the rest of the problem. I'm not going to write down the denominator now. We're just interested in the numerator, that it equals this expression up here. So we'll have minus 5x squared minus 20 plus 6x squared. 2x minus 3x is minus x minus 1. So we will have x squared minus x minus 21, which is exactly what we have there. Okay, we can now integrate this expression. So we'll have the integral of minus 5 over 2x minus 1 plus 3x plus 1 over x squared plus 4 dx. Again, we can split this into two separate integrals. So minus 5 over 2x minus 1 dx plus the integral of 3x plus 1 over x squared plus 4 dx. Okay, we can pull out the minus 5 from the first integral. What's left is the integral of 1 over 2x minus 1 dx. To integrate the second expression here, we're going to use a trigonometric substitution. So we're going to let x equal 2 tan theta. We do that because we'll have 4 tan squared theta plus 4, and the square identity tan squared theta plus 1 equals sec squared theta. So when we differentiate this, dx equals 2, the derivative of tan theta, sec squared theta, and then we have d theta. So we will have the integral of 3 times x, 3 times 2 tan theta is 6 tan theta plus 1 over x squared will be 4 tan squared theta, then we add 4, and dx is 2 sec squared theta d theta. Okay, so the first integral will be minus 5 ln 2x minus 1, and then we divide by the derivative of 2x, which is 2, so that's all over 2, plus the integral of 6 tan theta plus 1 over 4 times tan squared theta plus 1 times 2 sec squared theta d theta. Tan squared theta plus 1 is sec squared theta, so we're just going to replace that with sec squared theta, and then sec squared theta is going to cancel out. So that equals minus 5 over 2 ln 2x minus 1 plus 2 divides into 4 twice. So we can take out that half as a constant, and we are left with 6 tan theta plus 1 d theta. So minus 5 over 2 ln 2x minus 1 plus a half. And then we're going to split this up into two integrals. So the integral of 6 tan theta d theta plus the integral of 1 d theta. That equals minus 5 over 2 ln 2x minus 1 plus a half. Now here we're going to pull the 6 out of the integral. And then we have the integral of tan theta d theta plus the integral of 1 with respect to theta will just be theta, and we need the integration constant as well. So minus 5 over 2 ln 2x minus 1 plus a half times 6. The integral of tan theta is ln sec theta plus theta plus c. And now I have to express theta in terms of x. Recall that we let x equal 2 tan theta. So in other words, x over 2 equals tan theta. We draw a right angle triangle now, angle theta. X is the opposite side, 2 is the adjacent side. So our hypotenuse will then be 2 squared plus x squared. So we'll have 4 plus root 4 plus x squared rather. So equals minus 5 over 2 ln 2x minus 1 plus, and we'll bring the half into the bracket now. So half times 6 will be 3 ln sec theta is hypotenuse over adjacent. So it'll be root 4 plus x squared over 2 plus theta, right? Theta, we're going to take the inverse of this function here. So theta will be tan to the minus 1 x over 2. And that'll be a half. We're bringing the half into the bracket as well. So it's half theta. So it's half tan to the minus 1 x over 2. And then half times the object constant c is another object constant c. So that equals minus 5 over 2 ln 2x minus 1 plus, we can take this half out of the absolute value sign and bring it in front, so it's 3 over 2 ln 4 plus x squared is always positive. The square root of that is obviously also positive, so we don't need the absolute value sign anymore. So it will be ln root, we'll just write that as x squared plus 4 plus a half tan to the minus 1 x over 2 plus c, and that is the solution, the answer. X cubed minus 4x minus 1 over x times x minus 1 all cubed. As partial fractions is written as a over x plus b over x minus 1 plus c over x minus 1 all squared plus d over x minus 1 all cubed. All possibilities need to be included here, hence the denominator is x minus 1 all squared, x minus 1 all cubed. And that equals, once you found your partial fractions, we're not going to be doing the working out here, is 1 over x plus 3 over x minus 1 all squared minus 4 over x minus 1 all cubed. So the integral reduces to the integral of 1 over x plus 3 over x minus 1 all squared minus 4 over x minus 1 all cubed dx. Split it into 3 separate integrals now. So we have the integral of 1 over x dx plus the integral of 3 over x minus 1 all squared minus the integral of 4 over x minus 1 all cubed dx. I should bring a dx as well. Okay, so that equals ln x plus, we'll take the 3 out, of the integral of x minus 1 minus 2 dx minus 4 times the integral of 1, x minus 1 to the minus 3 dx. So that's ln x plus 3 times, so we'll have x to the minus 1. We can add 1 to minus 2, so it's going to be negative 1, and then we're dividing by negative 1 as well. So we're just going to change this plus 3 times negative 3 divided by negative 1 will just be negative 3. Then we'll have minus 4 times x minus 1, minus 3 plus 1 will be minus 2, and then we're dividing by negative 2 plus c, and then plus negative 4 divided by negative 2 is plus 2. So that equals ln x minus 3 over x minus 1 plus 2 over x minus 1 all squared plus c, and that's the final answer.